today we're going to be focusing on the importance of capacity, and we'll be looking at application requirements, device requirements, and some general guidelines for gaining more capacity. It is an essential element of wireless LAN design, implementation, monitoring, and support with modern networks, because we're no longer in that era where we can simply say we'll install a few access points and people will have wireless access, because we're now running critical applications, or we're marketing that we provide wireless access at hotels and other hospitality areas, arenas, and things like this. And when you market that you're providing wireless access and then people connect to the wireless network and do not have effective wireless access to the internet, let's just say they get a little bit frustrated. So to avoid that, we have to make sure that we've designed for capacity, and that's what we'll be looking at today. What we want to do then, as a general guideline for enhancing capacity, is drive clients to 5 gigahertz. Do everything you can to move as many clients as possible to 5 gigahertz APs. So with more channels in 5 gigahertz, it gives us a lot greater capacity, and we can enhance or accommodate greater capacity requirement demands because of this band. Now, there are several things we can do. You can use band steering. Now, this is a feature enabled on the AP, where the AP ignores initial 2.4 gigahertz probe requests and responds to 5 gigahertz probe requests from the same client in order to try to move them over to the 5 gigahertz band. You do have to monitor for orphan clients. There are some situations you can get into with band steering where clients do not steer well, and the AP needs to have some threshold to allow that client on. You can limit 2.4 gigahertz associations if the AP supports this, meaning you can go into the wireless LAN profile and control how many 2.4 gigahertz clients can associate. But once again, you have to be careful. For example, guest access, things like that, where you see a lot more 2.4 gigahertz clients because you can't control the device purchases. You have to make sure that you're obviously providing sufficient connectivity. And then you need to make sure you have sufficient 5 gigahertz coverage. So you've got to make sure the 5 gigahertz coverage that you need is there. Otherwise, the 5 gigahertz clients can't connect and they'll be going back over to 2.4 gigahertz. So a common mistake is to implement APs with 2.4 gigahertz and 5 gigahertz radios, enabling all the 2.4 gigahertz radios and creating similar cell sizes with 5 gigahertz as 2.4 gigahertz with power management operations. But then the problem is that you cannot implement as many 5 gigahertz APs because you're constraining the 2.4 gigahertz APs you can implement. So what do? Turn off the 2.4 gigahertz radio and have some APs that are just running the 5 gigahertz radio, or have APs that are 5 gigahertz only, which is of course harder to find. And then make sure you have properly configured clients. So many clients can be configured to prefer the 5 gigahertz band. They can be configured to use only the 5 gigahertz band, but that can be dangerous if they're clients that do leave your facility, simply because when you get out of the facility and they go to hotspots and things like that, there may simply not be a 5 gigahertz network to connect to, and so that client all of a sudden is unable to connect. So you have to be real careful with that, but you can certainly prefer the 5 gigahertz band. Does that work? Well, the answer is we don't really know for all devices. So there's a lot of secret sauce, hidden ways things work behind some of those toggles in client devices. And we're never really certain just how well they actually work or enhance connecting to 5 gigahertz unless we test ourselves. But enabling the feature is an important thing to do if indeed that feature is available in your clients.